The mist is still low over the Illinois floodplain when the archaeologist climbs the last few feet to the top of the mound. From here, the ground looks unremarkable: grass, gravel paths, a low ridge against the sky. Then the numbers arrive. 30 acres at the base, 100 feet high. 22 million cubic feet of earth carried basket by people with no wheels, no draft animals, no metal tools, and it was built in the middle of what most Americans were once taught was empty wilderness before Columbus ever crossed the Atlantic. Stand at the base and look up. You are looking at more moved earth than most modern construction crews handle in a year, moved one basket load at a time, by hands, over generations. That single fact is easy to say and hard to actually absorb. This is Monk's Mound, and it sits in southwestern Illinois, just across the Mississippi River from modern St. Louis. On a clear day, you can see the arch of that city's skyline from the summit, glass and steel, rising a few miles away from a hill of packed earth that predates it by nearly 1,000 years. For a long time, that was the whole story most people knew. A hill, maybe a burial site, maybe nothing at all, just a natural rise in the land that happened to look a little too symmetrical. That underestimation was not an accident. It came from an old, deeply rooted assumption about what pre-Columbian North America was supposed to look like. Before this discovery reached its full scale, the accepted idea was simple. North America north of Mexico, in the centuries before Europeans arrived, was pictured as a patchwork of small, mobile groups, hunting, gathering, moving with the seasons, living in scattered villages of a few dozen people. Cities, in the European or Mesoamerican sense, were not supposed to belong to this picture. Rome had cities, Baghdad had cities, the Maya had cities. The interior of North America, according to the textbooks of 100 years ago, did not. That assumption ran so deep that when European settlers first encountered the mounds scattered across the Mississippi and Ohio River valleys, many refused to believe Native Americans had built them at all. 19th century writers invented an entire vanished people to explain the earthworks. A lost mound builder race, sometimes imagined as Vikings, sometimes as a lost tribe of Israel, sometimes as refugees from a sunken continent. Anything, it seemed, was easier to believe than the idea that the ancestors of the people already living on this land had organized the labor, the food supply, and the engineering to build something this large. That theory was wrong, and later archaeology corrected it clearly. But the myth reveals something important about how badly the old model underestimated what had actually happened here. Because Monk's Mound was never just a mound. It was the center of a city. At its peak, around 1100 AD, this city covered roughly 6 square miles. It held close to 120 earthworks of different shapes and sizes, platform mounds, ridgetop mounds, burial mounds, arranged around a planned central plaza. Somewhere between 70 and 80 of those mounds still exist today. The rest were leveled over the centuries by farming, roads, and expansion, long before anyone understood what they were destroying. And the population living inside that footprint was not small. Estimates from the dense urban core alone run from 10,000 to 20,000 people. Some researchers, factoring in the surrounding farming villages and outlying settlements, push that number as high as 40,000. Even the more conservative number is worth sitting with for a moment, because of what it means when placed next to a very different city, on a very different continent, at the exact same point in history. In the 12th century, London, the largest city in England, held a population estimated at somewhere between 10,000 and 18,000 people. That is not a rough comparison. That is the same order of magnitude in the same century. As the population living in the floodplain across from modern St. Louis, if the higher estimates for this American city are correct, it may have briefly outsized London itself. And if that is true, then a place most people have never heard of was, for a window of time, one of the larger cities on Earth. This is where the old picture starts to break down. Not because anyone lied about it, but because no one was looking for it. The framework being used to study early America simply did not include the possibility of a city this size existing here, this early, without European contact, without the wheel, without iron tools, without a written language in the form Europeans would have recognized as one. The name most people use for this place is not even its own. Archaeologists call it Cahokia, borrowed from a Native American group who lived in the region centuries after the original city had already been abandoned. Whatever the people who actually built Monk's Mound and the city around it called themselves, and called their home, has not survived. That gap is not a minor footnote, it sits at the center of everything that follows. This was a civilization capable of organizing tens of thousands of people, moving millions of cubic feet of earth, and building a city that could stand shoulder to shoulder with London, and it did all of that without leaving behind the one thing that would let its own voice speak for itself. Picture the moment archaeologists began to take this seriously. Decades after the racial theories about a vanished mound builder race had finally been abandoned, the site had already been scarred. A road cut straight through part of the plaza. A section of one mound had been leveled for a subdivision before anyone stopped to ask what was underneath it. Even in the 20th century, this place was treated less like a monument and more like an inconvenience. That is easy to forget standing here now, with the mound protected, the grass mowed, tourists occasionally walking the wooden staircase built into its side. But the site nearly lost most of its physical evidence before it ever had the chance to tell its own story. What eventually forced a reconsideration was not one discovery, but an accumulation of them: soil surveys, aerial photography, and later, ground-penetrating radar, all revealing that the visible mounds were only part of a much larger, deliberately organized landscape. The city had a plaza roughly the size of dozens of football fields. It had residential zones stretching outward in every direction. It had evidence of craft production, copperworking, shell engraving, pottery, happening at a scale that implied specialists working full-time, not just subsistence farmers doing everything themselves in whatever hours were left after the harvest. None of that fits comfortably inside the old model of small, mobile, unstratified societies with no permanent leadership. And the scale of Monk's Mound itself remains the clearest. Most physical piece of evidence for what this society was capable of: 22 million cubic feet of earth, no wheelbarrows with wheels, baskets carried on the back and shoulder instead, no oxen, no horses, no large domesticated pack animals of the kind used to build monuments elsewhere in the ancient world. Just people, coordinated labor, and enough social organization to plan, direct, and sustain a construction project that would have taken generations to complete in distinct building stages, each one visible today as a separate layer of fill beneath the modern grass. That kind of coordination does not happen by accident, and it does not happen in a society without leadership, without shared belief, and without some system for organizing thousands of workers toward a single goal over multiple lifetimes. The mound is not just dirt. It is evidence of decision-making on a civic scale, the kind of decision-making that, until fairly recently, most historical models reserved for societies with written bureaucracies and centralized states of a very different kind, built in stone on a different continent. Walk the path that circles the base today, and you will pass families having picnics, joggers, a scattering of interpretive signs. Nothing about the modern scene warns you that you are circling the footprint of a lost metropolis. If you stood here before the 20th century excavations began, nothing about the place would have told you either. You would have seen a hill, some grass, maybe a few smaller rises further off toward the tree line. You would not have immediately seen a civilization-changing discovery. You would have seen earth and silence and the outline of something whose meaning had not yet been asked for. Today, the site carries an official designation that would have seemed unthinkable to the 19th century writers who doubted Native Americans built it at all. In 1982, the United Nations recognized it as a World Heritage Site, placing it alongside the pyramids of Giza and the temples of Angkor. That recognition did not arrive because someone found a new artifact in the grass. It arrived because decades of excavation, soil analysis, and comparison with other Mississippian sites forced a reassessment of what this place actually was. Not a curiosity on the edge of American history, but one of its central, unresolved chapters. Consider what the builders lacked: no iron tools to cut timber or shape stone, no wheel to move loads across the plaza. No draft animals, no horses, no oxen, none of the large domesticated species that pulled sledges and carts on other continents. Every basket of earth that went into Monk's Mound was carried by a person up a slope and packed by hand into place. Multiply that single basket load by the millions, spread the labor across generations of builders who never saw the final structure completed. And you begin to understand why archaeologists now describe this not as a mound, but as a monument to sustained, coordinated intention. That intention shows up in details easy to miss on a casual visit. The mound was not built in one continuous pour of earth. Excavated cross-sections reveal distinct construction stages, each one a separate episode of building. Sometimes separated by pauses long enough for grass and even small trees to take root on the surface before the next layer was added on top. Each stage required someone to make a decision, to enlarge, to reshape, to add height. Each decision required labor, coordination, and, most likely, a belief system or political structure capable of convincing large numbers of people that this effort mattered enough to repeat across their lifetimes. None of that fits the caricature offered by the old model of small, unorganized societies drifting across the landscape in search of the next hunting ground. And yet, for much of the 20th century, that caricature persisted in American classrooms, in museum placards, in the popular imagination of what before Columbus was supposed to look like on this part of the continent. The gap between the caricature and the physical evidence sitting quietly in an Illinois field is, in some ways, the real subject of this story. You can feel that gap most clearly standing at the top of the mound at dusk, when the tourists have left and the modern skyline across the river starts catching the last orange light. From up here, it is not hard to imagine smoke rising from thousands of hearths spread across the floodplain below, voices carrying across a plaza the size of dozens of football fields. Canoes moving along the river that once served as this city's highway. None of that imagined scene is documented fact. It is atmosphere, built from what the physical evidence allows us to infer. But the mound itself, the dirt beneath your feet, is not atmosphere. It is measurable, datable, and undeniable. Something enormous happened here. The mound was only the beginning. The number that first pulled researchers into a deeper investigation was not the height of the mound or the volume of earth inside it. It was the population living around it, a number large enough to stand next to a European capital and not look out of place. But a city this size does not appear gradually, the way most ancient cities do, growing outward in slow rings over centuries. Something else happened here, and when researchers looked closely at how fast this place actually grew, the timeline itself became the next problem. In a research office far from the floodplain, a demographer lays two population charts side by side. One is labeled London, the other Cahokia. They are not supposed to belong on the same page. One traces a medieval European capital, the seat of a kingdom, a city that would go on to become one of the largest in the world. The other traces a Mississippian settlement most Americans have never heard of, built from earth and timber in a river valley in what is now Illinois. And yet, in the 12th century, the two lines sit almost on top of each other. London's population around the year 1100 is estimated by historians at roughly 10,000 to 18,000 people. That number comes from tax records, church registries, and the slow, careful reconstruction work of medieval demographers working with fragments of documentation. Cahokia left no comparable paper trail, no parish rolls, no census takers, no written language recognizable in that form. Its population has to be reconstructed a different way, through excavation density, the number and size of house patterns uncovered in the soil, the volume of waste and food remains left behind, and the total footprint of the settled area. Using that method, archaeologists place Cahokia's dense urban core at somewhere between 10,000 and 20,000 people at its peak, with some researchers extending the estimate to the broader metropolitan area, the surrounding farming villages and satellite communities that fed and supplied the city, as high as 40,000. Put those numbers next to each other, and the comparison becomes hard to dismiss as coincidence. At the low end, Cahokia's core population sits comfortably inside the same range as London's. At the high end, it may have exceeded it. If the highest estimate is accurate, no city within the borders of the modern United States would match or surpass Cahokia's population again until Philadelphia crossed 40,000 residents in the 1780s, nearly 7 centuries later. That is worth pausing on. Before this discovery reshaped the timeline, the working assumption inside American historical education was that urbanization on this continent, in any meaningful sense, began with European colonization. Villages, yes. Settlements, yes. But cities, dense, planned, socially stratified population centers, were treated as something that arrived with the ships. The Cahokia data does not just complicate that assumption, it contradicts it directly, placing a city of comparable size to a European capital squarely in the middle of the period historians once described as empty. The physical footprint backs up the numbers. At its height, the city covered close to 6 square miles, its high-density central occupation zone alone spanning nearly 2 square kilometers. Within that space stood roughly 120 earthworks of varying size and function, residential platforms, ceremonial mounds, burial mounds, arranged not randomly, but around a central plaza large enough, by some comparisons, to hold dozens of modern football fields side by side. Walk that plaza today, and you will find open grass, a scattering of interpretive signage, and quiet. It takes a conscious act of imagination to fill it back in. The smoke from thousands of cooking fires drifting low over the floodplain in the evening, footpaths worn smooth by daily foot traffic between residential clusters. The sound of a crowd gathered for a ceremony or a game near the base of the mound. None of that reconstructed noise is documented fact. It is atmosphere built on the measurable emptiness the archaeology has left behind. House patterns, hearths, refuse pits, the physical residue of a crowd that is no longer there. That density did not stay contained within the 6 square miles of the urban core. Excavations to the west of the main mound complex, carried out in the early 21st century, uncovered previously unknown residential areas that expanded the known footprint of the settlement significantly beyond what earlier surveys had mapped. Each new residential zone found under a modern soybean field or highway easement pushed the population estimate a little higher, and each upward revision made the London comparison a little harder to treat as an exaggeration. Here is where the story requires some caution, because population estimates for a pre-literate society, reconstructed centuries later from soil and structural remains, are not the same kind of number as a tax census. Archaeologists openly debate the exact figure, and the range given in the research, 6,000 on the very low end, 40,000 on the very high end, is wide enough that treating any single number as final would be dishonest. What can be said with more confidence is the shape of the pattern. This was, by any reasonable estimate, one of the largest population concentrations in North America before European contact, and by several estimates, one of the largest urban populations anywhere in the world during that specific historical window. It helps to understand why the comparison to London specifically keeps surfacing in the research, rather than a comparison to a larger city like Baghdad or Kaifeng, both of which vastly outsized both London and Cahokia in this period. The London comparison is not chosen because it is the most impressive available benchmark. It is chosen because London represents the assumed ceiling of what urban civilization was supposed to look like in the medieval world familiar to most Western audiences: a walled city, a monarchy, a cathedral under construction, a population dense enough to strain its own sanitation. Placing Cahokia beside that specific benchmark is not about proving Cahokia was the largest city on Earth. It never claimed to be. It is about showing that a population matching a recognized medieval European capital existed on this continent, organized without the institutions historians had assumed were necessary to produce a population that size. And a city does not reach that density by accident or by the slow accumulation of a few families over many generations, the way most pre-modern cities grew. Most ancient urban centers expand the way a tree grows, a narrow trunk widening gradually outward, ring by ring, over centuries, as trade routes stabilize and agricultural surplus accumulates. When researchers began comparing Cahokia's excavated occupation layers against radiocarbon dates and the region's known population before this period, they did not find a slow widening trunk. They found something closer to an explosion, a population jump concentrated within a window of only a few decades, not centuries. That kind of growth curve raises a very different question than simple population size does. A city can be large because it took a very long time to become large. Or a city can be large because something happened: a migration, a political shift, a religious movement, an environmental opportunity that pulled thousands of people toward one place within a single human lifetime. The evidence at Cahokia points strongly toward the second possibility, and that possibility is far stranger than the number itself. Picture what the researcher comparing those two population charts is actually holding. On one side, centuries of English documentation, parish records, land surveys, the accumulated bureaucratic residue of a literate kingdom. On the other side, a stretch of Illinois farmland where the only surviving record is the dirt itself, postholes marking where a house once stood, a shallow depression where a hearth burned nightly for years, a scatter of broken pottery and a trash midden that can be dated by the layer it sits in. Reconstructing a population from that kind of evidence takes patience and a particular kind of skill, counting house patterns per excavated block, estimating how many people typically lived in a structure of that size, then extrapolating across the full extent of the settlement. It is not guesswork, but it is also not arithmetic performed on a clean historical ledger. Every number that comes out of that process carries a margin of uncertainty attached to it, and honest researchers say so. That honesty matters, because the wide range in the estimates, as low as 6,000, as high as 40,000, has occasionally been flattened in popular retellings into a single, more dramatic figure. It is easy to see why the highest number gets repeated. It makes for a cleaner headline, a bigger contrast with London, a more satisfying reversal of the old assumption. But the responsible version of this story sits inside the uncertainty rather than erasing it. What can be said with confidence is that even the low end of the range places Cahokia's core population on par with a major medieval European capital. What cannot be said with the same confidence is the exact number of people who filled the plaza on a given afternoon 1,000 years ago. Still, even the conservative estimate forces a reckoning with how differently North America has to be imagined in this period. If you stood at the edge of the plaza in the year 1100, you would not have seen isolated homesteads scattered across an empty floodplain. You would have seen residential clusters extending in every direction, smoke rising from cook fires at a density that implied close neighbors rather than distant kin, footpaths worn into the earth by daily foot traffic moving between houses, workshops, and the ceremonial center at the heart of it all. The city would have had a rhythm to it: morning activity around the hearths, movement toward the fields at the edge of the floodplain, gatherings drawing crowds toward the plaza for events whose exact nature can only be inferred from what was left behind. That density brought its own pressures, the kind any city of that size has to solve or fail. Waste disposal for a population in the tens of thousands, on a floodplain prone to seasonal flooding, would have required constant management. Feeding that many people meant an agricultural system organized well beyond the scale of a single-family plot, outfields extending across the richest soils in the region, a logistics network moving surplus maize into the urban core, storage systems capable of carrying a population through the lean months between harvests. None of this is speculation built from imagination alone. It follows directly from the basic math of population density. A settlement this size simply could not have survived without solving these problems, and the archaeological record, refuse patterns, storage pit remains, evidence of specialized maize processing tools shows the outlines of how it did. This is also where the excavations to the west of the main mound complex become important. For decades, population estimates for Cahokia were built largely from surveys of the visible mound and plaza core, the part of the site most protected, most studied, most familiar to visitors today. But in the early 21st century, archaeological work ahead of highway and utility construction uncovered residential zones extending well beyond that familiar boundary, revealing house patterns and occupation layers in areas nobody had previously mapped as part of the settlement. Each new residential cluster found beneath a modern field pushed the known extent of the city outward and pushed the population estimate upward along with it. The unsettling part of this pattern is not any single new number, it is the trend. Every time researchers have looked more carefully at the edges of Cahokia, the city has turned out to be larger than the previous survey suggested, which raises the uncomfortable possibility that the true extent of the settlement and its true population may still be underestimated even now. But a city this size does not build itself in a few generations by accident. And that raised a stranger question for the researchers working through the soil layers beneath the plaza. How fast did this actually happen? And what could have pulled that many people to one floodplain in the American Midwest at exactly the same time? Cut a vertical slice into the earth near the old city center, and the soil itself starts to read like testimony, layer by layer. The way growth rings testify inside a felled tree. Thin bands of darker, ash-flecked fill mark one period of occupation. A pale, compact layer above it marks a pause, or a flood, or a fresh episode of construction. Radiocarbon samples, pulled from charcoal, embedded in these layers, and cross-checked against the earlier population data, tell a story that does not match the way cities are supposed to grow. Most ancient urban centers expand slowly. A small settlement attracts trade. Trade brings surplus. Surplus supports more people. More people means more labor, more construction, more complexity, a process that typically plays out over centuries, generation stacking on generation in a gradual widening. That is the old assumption researchers carried into their study of the American bottom, the fertile floodplain where Cahokia sits. Before this discovery, the expected model was straightforward. A modest village slowly thickens into a town, and the town slowly thickens into something larger, tracking population growth at a pace no faster than the surrounding region could naturally sustain. The dates from Cahokia do not support that model. Estimates drawn from excavated occupation data place the local population, before the boom, at somewhere between roughly 1,000 and 2,800 people, a modest, unremarkable settlement, similar in scale to other communities scattered along the Mississippi at the time. Then, within a window archaeologists place, between approximately 1050 and 1100 AD, that number jumps to somewhere between 10,000 and 15,000 people concentrated in the high-density core alone. That is not a gradual widening. That is close to an order of magnitude increase within 1 to 2 human generations, a shift so abrupt that Timothy Pocketat, one of the archaeologists who has spent decades excavating the site, has described it using a term borrowed from cosmology, a Big Bang. The phrase is deliberately provocative, and it is easy to misread as hyperbole aimed at a modern audience raised on dramatic headlines. It is not. The underlying claim is a careful one. It does not mean the city appeared overnight or that a single dramatic event triggered instantaneous urbanization. It means that when the excavated evidence is laid out chronologically, the growth curve looks less like the slow, patient climb typical of pre-modern cities, and more like a rapid convergence, as if something pulled a large number of people toward this specific stretch of floodplain within a compressed span of time, rather than the city simply outgrowing its neighbors over the ordinary pace of centuries. That raises an immediate and obvious question. What could cause several thousand people to converge on one location within a single generation, in a period with no ships, no roads in the modern sense, no centralized government issuing resettlement orders? The clue that has drawn the most sustained research attention is climatic, and it comes not from the soil at Cahokia itself, but from tree rings and lake sediment records collected across the wider Midwest. Around the same window, when Cahokia's population began its rapid climb, the regional climate shifted into one of the wettest 50-year stretches recorded in the last 1,000 years. Warmer temperatures combined with increased rainfall to create unusually favorable growing conditions across the American bottom. Conditions that would have dramatically boosted maize yields in a region whose entire food economy depended on that single crop. Researchers Larry Benson, Timothy Pocketat, and Edward Cook, publishing their analysis in the journal American Antiquity, argued that this climatic window helps explain both ends of Cahokia's story: the sudden agricultural surplus that could have supported a rapidly growing population at the beginning, and centuries later, the reversal of that same climate pattern that likely contributed to the city's decline. A good growing season, on its own, does not explain why thousands of people would abandon their existing homes and move to a new settlement, rather than simply expanding where they already lived. Agricultural surplus can explain how a population boom was sustained once it began. It does not, by itself explain why the boom concentrated so heavily in one specific place rather than spreading evenly across the floodplain's many suitable farming sites. That gap between what the climate data can prove and what it cannot fully explain is exactly the kind of honest uncertainty that responsible researchers have kept alive in the debate. Rather than papering over it with a tidier story than the evidence actually supports, the evidence suggests that favorable climate created the conditions for growth. It does not, on its own, prove what convinced people to gather specifically here, rather than anywhere else along the river. This is where the investigation has to widen beyond agriculture and into something harder to measure directly: belief, prestige, and the pull of a place already becoming known as significant. Some researchers argue that the earliest stages of mound building at this location, predating the population boom by generations, had already established the site as a ceremonial center of some regional importance, a place people traveled to for gatherings, rituals, or trade before it became a city in the full sense. If that is correct, the population surge after 1050 may represent people converging on a place that already carried religious or political weight, arriving not simply because the land was fertile, but because the place itself meant something. Others remain more cautious, pointing out that the evidence for this earlier ceremonial significance is thinner than the evidence for the later population boom itself, and that reconstructing motive from soil and pollen is inherently more speculative than reconstructing population density from house counts. What can be said with more confidence, without overreaching into the unprovable territory of belief and motive, is the physical fact of the timing itself. The climatic shift and the population surge occur in the same narrow window. The agricultural capacity to support a much larger population appears at nearly the same moment that population appears. Whether the climate was the trigger, the enabler, or simply a fortunate coincidence layered on top of a social or religious pull that the archaeological record cannot fully capture, remains an open question, one that continuing excavation and refined dating methods continue to probe. And a sudden convergence of people onto one stretch of floodplain does not, by itself, produce an organized city. It could just as easily have produced a sprawling, chaotic camp, clusters of newcomers settling wherever there was open ground, with no larger plan connecting one neighborhood to the next. That is not what the excavated layout of Cahokia shows. When archaeologists mapped the orientation of the mounds, the plaza, and the surrounding residential zones against each other, they did not find the disorganized scatter you would expect from an unplanned refugee settlement. They found alignment. They found a grid. Look closer at how that timeline was actually built, because the method matters as much as the conclusion. Tree rings preserve a year-by-year record of rainfall and temperature, written into the width and density of each growth band. A wide ring means a good year. A narrow one means stress. Layered sediment pulled from the bottom of nearby lakes preserves a similar record in miniature, pollen grains, charcoal flecks from burning, and chemical traces that shift with changing land use on the shoreline above. Neither record was collected at Cahokia specifically for the purpose of explaining a city. Both were originally environmental data sets, built to reconstruct regional climate history. It was only when researchers laid those climate records directly against the excavated population and construction timeline from the city itself that the overlap became impossible to ignore. The warmest, wettest 50-year stretch in the regional tree ring record lines up almost exactly with the sharpest population increase found in the excavated soil. That kind of overlap is the moment a scientific method stops being background information and starts functioning like a witness. A tree ring cannot tell you why people moved. It can only tell you that the growing conditions during the years in question would have made a large agricultural surplus possible. A lake sediment core cannot tell you what a person believed. It can only tell you what was burning, growing, and washing into the water during a given decade. But when a climate record this favorable appears at the exact moment a population this large converges on one floodplain, the coincidence stops looking like a coincidence and starts looking like cause and effect, even if the precise mechanism connecting the two remains, honestly, only partly understood. You can stand at the edge of the floodplain today and try to picture what that decade might have looked like on the ground. Fields of maize, taller and denser than in a lean year. Storage pits filling faster than usual. Word of a good harvest traveling along the river to smaller communities upstream and downstream. Communities that may have been struggling through the same climatic instability that was, paradoxically, working in this specific location's favor because of its particular soil and drainage. None of that mental picture is documented fact. It is inference, built cautiously from what the tree rings and the excavated storage features allow researchers to reconstruct. But it offers a plausible, evidence-grounded answer to a question that would otherwise remain a total blank, not proof of exactly why people came, but a believable account of why this specific place, at this specific moment, might have looked like somewhere worth moving to. The debate among researchers is not about whether the climate shifted. The tree ring and sediment data on that point are strong and widely accepted. The debate is about how much weight to give the climate as the actual driver of urbanization, as opposed to a background condition that made an already developing social or religious movement easier to sustain. Some researchers lean heavily on the agricultural explanation, treating the population boom largely as an economic response to a temporary surplus. Others argue that economics alone cannot explain why the growth concentrated so heavily around one ceremonial center rather than spreading evenly to dozens of similarly fertile spots along the same floodplain, and point instead to the possibility that this location had already begun accumulating religious or political significance before the boom, pulling migrants toward a place that meant something, not merely a place that grew good corn. Neither side of that debate claims certainty, and that restraint is itself part of the evidence, a sign that the researchers closest to the material are more interested in getting it right than in settling on the most dramatic possible answer. What both sides agree on is the shape of the event, fast, concentrated, and coincident with a documented climatic anomaly. What remains open is the deeper mechanism, whether people were pulled by opportunity, by belief, or by some combination the archaeological record may never fully separate. A sudden city needs a plan. And when archaeologists looked at how Cahokia was laid out, at the way its central axis lined up, not just with the mounds around it, but with the movement of the sun itself, they found something that by the old model of what this region's societies were supposed to be capable of, should not have existed here yet at all. South of Monk's Mound, archaeologists mapping a stretch of open ground began noticing something the naked eye would never catch: a ring of dark stains cut into the pale subsoil, evenly spaced, curving in a wide arc across the excavation grid. Each stain marked the spot where a massive wooden post had once stood, rotted away centuries ago, leaving behind only the discolored earth that had packed in around its base. Followed all the way around, the stains formed a circle more than 400 feet across, a structure archaeologists now call Woodhenge, deliberately echoing the name of its more famous stone counterpart on the other side of the Atlantic. Before this discovery, the working assumption about mound-building societies in North America was narrow and specific. Monumental construction aligned with astronomical events, structures built to track solstices, equinoxes, and seasonal turning points, was associated with societies already labeled advanced by an older generation of scholars: the megalithic builders of Stonehenge, the pyramid architects of Mesoamerica, the temple engineers of the ancient Near East. Mound-building cultures in the Mississippi Valley were rarely placed in that category. They were assumed to build for burial, for status, for ceremony in a general sense, not for precise, repeatable astronomical observation requiring sustained knowledge passed down across generations. Woodhenge complicates that assumption directly. At least one of its posts has been dated to approximately 950 AD, placing its earliest phase before the population boom described in the previous chapter, meaning some form of deliberate, astronomically minded construction was already underway at this location before the city around it exploded in size. Researchers studying the alignment of the circle found that specific posts corresponded to the position of the rising sun on the solstices and equinoxes, viewed from a fixed observation point at the center of the ring. Stand at that center point at sunrise on the right morning of the year, and the sun would rise directly in line with a particular post on the horizon. A level of precision that requires sustained observation over multiple years to calibrate correctly, not a single lucky guess. That precision matters because it reframes the entire city layout, not just this one structure. Once archaeologists had confirmed that Woodhenge tracked solar events with intention, they began re-examining the orientation of the city's other major features. The primary axis of Monk's Mound, the boundaries of the central plaza, the placement of secondary mounds relative to each other. What emerged was not the layout of a settlement that grew organically outward from a founding point, adding structures wherever convenient as the population expanded. It was the layout of a settlement planned around a cosmological grid from the outset, with cardinal orientation and solar alignment built into the city's framework from an early stage. This is the detail that most sharply overturns the old assumption. A city that grows organically tends to look messy from above, streets bending around obstacles, buildings added at odd angles as space allows, a footprint that reflects centuries of improvised decisions rather than a single unified plan. Cahokia's core does not look like that. It looks intentional. The scale of that intention is easy to underestimate until you try to imagine actually enacting it. Surveying a solar alignment without instruments beyond direct observation, communicating that alignment clearly enough that construction crews positioned posts and mounds correctly relative to a point they could not always see from where they were digging, and maintaining that plan's integrity across construction phases that, as the previous chapter's excavated soil layers show, sometimes paused for years at a time. None of this proves the builders possessed formal astronomy in the sense modern audiences might imagine. No instruments, no written star charts, nothing resembling an observatory in the classical sense. What the evidence shows is more specific and, in some ways, more impressive, sustained, careful observation of the sky, translated directly into permanent architecture, integrated into the daily and ceremonial life of a city being built at the same time. The posts were not decorative. They were functional, in the same sense a modern calendar is functional, a way of tracking time collectively, publicly, and precisely enough that an entire community could organize its ceremonial calendar around what the circle indicated. Caution belongs here too. Archaeologists disagree about exactly what every individual post in the Woodhenge complex was meant to track, and about how many phases of rebuilding the circle went through as the surrounding city grew and changed around it. The circle itself was apparently rebuilt at least once, with the number and position of posts shifting between phases. Some researchers argue for a purely solar calendar function tied to agricultural timing, helping the city's farmers know when to plant and when to expect the seasonal turn. Others argue the structure carried a more explicitly religious function, marking dates significant to ceremonies whose content has not survived in any form archaeology can recover. The physical alignment is not in serious dispute. The full meaning behind it remains, honestly, only partly reconstructed. What can be said with confidence is this: a society capable of building Woodhenge and capable of orienting an entire 6-square-mile city around the solar observations that Circle produced was operating with a level of collective planning, shared knowledge, and sustained institutional memory that the old model of small, unorganized river valley communities simply did not allow for. That old model has to be redrawn, not because anyone lied about it, but because the evidence buried beneath a modern soybean field turned out to be more sophisticated than the model anticipated. You can stand near the reconstructed circle today. Modern posts placed in the same excavated post holes, allowing visitors to watch the sunrise the way the city's original residents might have, and feel the specific eeriness of standing inside a working calendar built 1,000 years before your own. The wind moves through the open posts the same way it would have moved through the originals. The horizon has changed very little. What has changed is the meaning, what once looked, to early surveyors, like nothing more than a curious ring of holes in the dirt, now reads as evidence of a society tracking the sky with enough precision to build a city around it. It is worth remembering that this same ground, before it became Woodhenge, before it became a solar observatory embedded in a planned city, was ordinary floodplain, grass, silt, the kind of unremarkable riverside land found up and down the Mississippi for hundreds of miles. Nothing about the soil itself marked it as destined to become the center of a calendar system, precise enough to still function, in principle, if you rebuilt the post today. That transformation from ordinary ground to deliberate instrument did not happen by accident, and it did not happen quickly. It happened because generations of people decided this specific place was worth the sustained effort of watching, marking, rebuilding, and refining. Consider how the excavation of Woodhenge actually unfolded, because the discovery itself was less a single dramatic moment than a slow accumulation of pattern recognition across years of fieldwork. The first post holes were noted decades ago during salvage excavations ahead of highway construction, the kind of routine archaeological survey required before ground gets disturbed for a modern road. At first, isolated post holes scattered across a wide area looked like nothing more than the ordinary debris of a long inhabited site, fence lines, temporary structures, storage posts. It was only when researchers began plotting every post hole on a single map, rather than treating each excavation unit in isolation, that the circular pattern emerged. That is a useful reminder of how much of Cahokia's story has been recovered this way, not through one spectacular find, but through the patient work of connecting scattered fragments of evidence into a shape no single trench could reveal on its own. Once the circular pattern was recognized, the next step was determining what it actually tracked. Researchers used the position of the post holes, cross-referenced against known solar positions for the latitude of the site, to test whether specific posts aligned with sunrise on the solstices and equinoxes as viewed from a central observation post near the circle's middle. The alignments held up. On the summer solstice, the sun rose in a position matching one specific post on the eastern arc of the circle. On the winter solstice, a different post marked the point. The spring and autumn equinoxes lined up with a third, positioned to align with the front of Monk's Mound itself, suggesting the circle and the mound were designed in relationship to each other. Not as two unconnected structures that happen to share a neighborhood. That relationship is worth sitting with. It means the tallest, most labor-intensive structure at Cahokia, the mound this documentary opened with, the 22 million cubic feet of hand-carried earth, was positioned with direct reference to a solar calendar built from timber posts nearby. The mound was not simply a monument to scale. It was, at least in part, an instrument oriented to participate in the same system of sky tracking that the timber circle made visible on the ground. This is easy to misread as more mystical than it actually is. The instinct in popular retellings is to reach for language like ancient astronomers or sacred alignment, framing the discovery as evidence of hidden or esoteric knowledge. The more grounded explanation is also the more impressive one: a farming society, dependent entirely on a single staple crop, has an intensely practical reason to track the solar year with precision. Planting too early risks a late frost destroying the crop. Planting too late shortens the growing season and risks an early frost before harvest. A calendar this precise is not evidence of mysticism layered on top of agriculture. It is evidence of agriculture demanding precision, and a society organized enough to build permanent infrastructure to deliver it. At the same time, researchers are careful not to reduce Woodhenge to pure agricultural utility either. The circle's central point sat close to a series of elite burials and ceremonial structures excavated in the area now known as Mound 72, a connection explored later in this investigation, suggesting the solar calendar was woven into ceremonial and mortuary practice as much as into planting schedules. The two functions, practical and ceremonial, were likely never fully separate in the worldview of the people who built it. Imposing a modern division between science and religion onto a 1,000-year-old timber circle risks flattening a system of knowledge that almost certainly held both purposes at once, inseparably. A city that watches the sky that closely does not stay isolated for long. Tracking the sun with this level of precision implies a stable, settled population with time and resources to dedicate to something beyond immediate survival, the kind of surplus and specialization that tends to accompany trade, not isolation. And when researchers began tracing the origin of the raw materials found buried across Cahokia's mounds and workshops, they found exactly that, evidence the city was pulling in resources from hundreds, and in some cases well over 1,000, miles away. Pull open a museum storage drawer at the Illinois State Archaeological Survey, and you find a small tray of raw copper nuggets, dull red-brown, cold and heavier than their size suggests. You could hold one in your palm and mistake it, at a glance, for an ordinary stone. until you notice the faint metallic sheen catching the light where a corner has been rubbed clean. They were not mined anywhere near the Mississippi floodplain. Their chemical signature points north, toward deposits around the Great Lakes, hundreds of miles from where they were eventually shaped into ornaments and buried at Cahokia. In the drawer beside it, a scatter of marine shell beads, some worn smooth from handling, others still showing the faint ridges of the mollusk shell they were cut from. Those did not come from anywhere near a lake either. Their origin traces to the Gulf Coast, over 1,000 miles to the south. Before this evidence accumulated, the working assumption about interior North American societies in this period was one of relative isolation, regional communities trading modestly with immediate neighbors, but with little capacity for sustained, long-distance exchange spanning a continent's worth of geography, in an era with no ships built for open water, no wheeled carts, no permanent roads. The materials recovered from Cahokia's mounds and workshop areas do not fit that model. Copper, Mill Creek chert, quarried from a specific outcrop in southern Illinois, marine shell, and shark teeth from Gulf Coast waters all turn up here, hundreds to well over 1,000 miles from their points of origin, worked into finished objects by artisans living in the city. This is where the physical evidence forces the story to expand outward from the city itself. If raw copper from the Great Lakes region is showing up in Cahokia workshops, that copper did not simply walk there. It moved through some combination of direct trading expeditions, chain trade passed hand to hand between neighboring communities, or organized journeys undertaken specifically to acquire prestige materials. The same logic applies to the marine shell and shark teeth arriving from the opposite direction, out of the Gulf. Whichever mechanism moved these materials, the practical result is the same. Cahokia sat at the convergence point of an exchange network stretching across a meaningful portion of the continent, pulling raw materials in from multiple directions simultaneously. What the city's artisans did with those materials once they arrived complicates the picture further. This was not simply raw resource accumulation for its own sake. Workshops within the city processed copper into sheet ornaments, headdress components, and jewelry, worked with a level of skill that implies specialization. People whose primary occupation was this craft, not farmers doing metalwork in whatever spare time the growing season allowed. Marine shell was cut, drilled, and polished into beads used in some of the city's most elaborate burials, including the tens of thousands of beads later found arranged in a specific and deliberate pattern within Mound 72. Carved stone tablets, including a well-known example depicting a human bird figure now referred to as the Birdman tablet, show a level of representational sophistication, a recognizable, repeated iconographic figure, rendered with intentional artistic choices rather than crude approximation, that argues against any lingering assumption that this was an unsophisticated frontier culture working with borrowed ideas it did not fully understand. The implication reaches beyond craftsmanship. A trade network this extensive requires more than the physical movement of goods. It requires shared understanding across distant communities about what these materials meant, what they were worth, and how they should be exchanged. A kind of common cultural currency that could only develop through sustained, repeated contact over generations. Copper and marine shell were not simply attractive raw materials picked up opportunistically. In Mississippian iconography more broadly, both materials carried symbolic weight tied to concepts of the upper and lower worlds, ancestral power, and elite status. Moving these specific materials across such distances suggests the trade network was carrying ideas and belief systems alongside the physical goods themselves, a possibility that is harder to prove directly than the movement of the objects, but one that many researchers find difficult to avoid given how consistently these same materials appear, worked in similar styles, across other Mississippian sites far from Cahokia. That last point deserves caution. Whether the spread of these materials and their associated iconography reflects direct migration of people, active missionary-style religious spread, formalized trade partnerships between distant elites, or a slower, less centralized diffusion through generations of contact between neighboring communities remains genuinely debated. The physical evidence, the materials themselves, their datable origin points, their presence at Cahokia in finished form, is solid. The social mechanism connecting the dots between origin and destination is the part that researchers continue to reconstruct carefully, resisting the temptation to flatten a complicated process into a single clean narrative. Picture the scale of coordination this implies on the ground, without overstating what can actually be proven. Someone in a community near the Great Lakes had to extract copper from a deposit, likely through labor-intensive surface mining or collection of exposed nuggets. That copper had to be transported, whether directly or through a series of intermediary communities, across hundreds of miles of forest, river, and open land, eventually arriving in the hands of an artisan working within sight of Monk's Mound. The same journey, in reverse geography, applies to shell moving up from the Gulf. Multiply that by the volume of material actually recovered from Cahokia's excavated context, and you are looking at a sustained system, not a handful of isolated exchanges. It helps to look closer at one specific material to understand how researchers actually trace an object back to its point of origin, rather than simply asserting it came from far away. Mill Creek Chert offers one of the clearest examples. This particular type of stone occurs naturally in only a limited number of outcrops in southern Illinois, and it has distinctive mineral characteristics that allow geologists and archaeologists to match a work tool back to its source outcrop with a fair degree of confidence. Mill Creek Chert was prized at Cahokia specifically for producing large hoes used in maize agriculture, the same crop economy discussed in earlier chapters as the engine behind the city's population boom. Finding these hoes, made from a stone with a single identifiable regional source, distributed across excavated agricultural contexts throughout the city, demonstrates a working trade and distribution system operating at a genuinely large scale, not a handful of prestige items passed between elites. Copper tells a similar story through a different method. Trace element analysis, essentially a chemical fingerprint of the metal, allows researchers to compare copper recovered from Cahokia against known deposits from different regions, including the well-documented copper-bearing formations around Lake Superior. While debate continues over exactly which specific deposits supplied which specific artifacts, the broader conclusion holds: the copper was not local. Cahokia had no native copper source of its own. Every piece of worked copper found in its mounds and workshops arrived from somewhere else, carried by people willing to undertake or participate in a chain of exchanges leading to a journey of hundreds of miles. The shell tells the most dramatic version of this story. Because of the sheer volume involved, and because unlike stone or metal, shell survives in the archaeological record as a direct, physical trace of a warm ocean shoreline transported into a cold Midwestern floodplain. Marine shell recovered from Cahokia includes species that live exclusively in the warm waters of the Gulf of Mexico. Species that cannot be confused with any freshwater mollusk available locally along the Mississippi. When later chapters examine the burial complex known as Mound 72, the scale of shell present there becomes especially significant. Tens of thousands of individual shell beads, cut, drilled, and arranged with clear, intentional patterning, representing an enormous cumulative investment of both raw material acquired from 1,000 miles away and skilled labor spent shaping it once it arrived. Consider what this trade network implies about the people managing it, beyond simply the artisans doing the physical work of shaping copper and shell. Someone had to organize expeditions or maintain relationships with distant trading partners, reliably enough that specific, rare materials kept arriving over multiple generations rather than through a single lucky exchange. Someone had to determine what Cahokia itself had to offer in return, likely surplus maize, finished craft goods, or the kind of religious and political prestige that came from association with what was becoming the region's most significant ceremonial center. None of that organizational structure survives as a written record. It survives only as an inference drawn from the consistency and scale of the archaeological pattern. This was not opportunistic scavenging of occasional interesting rocks and shells. It was a functioning system, sustained across decades. That system also tells us something about how Cahokia's influence extended beyond its own population figures. A city of 10 to 20,000 people, however large by regional standards, does not by itself explain a trade network spanning a meaningful fraction of a continent. That network required willing participation from dozens or hundreds of other communities along the routes connecting the Great Lakes, the southern Illinois quarries, and the Gulf Coast, communities who chose, for reasons of their own, to move materials toward this particular floodplain, rather than keep them for themselves or trade them elsewhere. Cahokia's true reach, in other words, extends well past its own city limits into a web of relationships that current archaeology can trace through the objects, even where it cannot fully reconstruct the social agreements that moved them. That reach is easy to underestimate from the modern vantage point of a quiet historic park in Illinois. Standing at the edge of the reconstructed plaza, there is nothing in the immediate landscape to suggest a connection to the Gulf of Mexico or the shores of Lake Superior. But hold one of those shell beads up to the light, turn it over, and you are holding a physical link and a chain that once stretched across a meaningful portion of a continent, carried, traded, and finally buried here, at the center of a city whose name its own builders never wrote down. All that wealth and connection was flowing toward one place, and underneath one of Cahokia's smaller mounds, in a location that looked, before excavation began, no more remarkable than dozens of other rises scattered across the site, archaeologists found where a significant portion of that wealth ended up, not stored in a treasury, but buried with the dead, arranged with a level of care that would eventually force a complete rewrite of who researchers believed had been buried there in the first place. In 1967, excavators working a modest ridgetop mound south of Monk's Mound, a mound so unassuming it had never drawn the attention given to the larger earthworks nearby, easy to walk past without a second glance, began uncovering something that would keep archaeologists reinterpreting it for more than half a century. Beneath the surface, arranged on an elevated platform, lay a bed of more than 10,000 marine shell beads, cut and laid out in the unmistakable shape of a bird, a falcon, wings and tail extended, head positioned beneath where a human skull rested at the center of the arrangement. This was Mound 72, and the burial found within it would come to be known as the beaded burial, or, because of the imagery surrounding it, the Birdman burial. The original excavation, led by archaeologist Melvin Fowler, identified what appeared to be a central figure of extraordinary importance, a high-status individual, interpreted at the time as a powerful male ruler, laid out with immense ceremony atop the shell bead falcon. Surrounding him, in graves layered above and around the central platform, lay additional individuals, interpreted in the original analysis as attendants or retainers, most identified at the time as male. This reading fit comfortably into a broader model that had already taken shape in American archaeology: a male-dominated political hierarchy, a warrior chief figure at the top, and Mound 72 as evidence of that structure carried into death. For nearly 50 years, that interpretation became something close to the standard model, cited in textbooks, museum exhibits, and academic literature as the clearest single piece of evidence for how Mississippian society organized its highest levels of political and religious power. Then, the bones themselves were re-examined. In 2016, a team led by archaeologist Thomas Emerson of the Illinois State Archaeological Survey went back through the skeletal remains recovered from Mound 72 in the 1960s, applying updated bioarchaeological methods that had not existed at the time of the original excavation. What they found complicated the standard model directly. The beaded burial complex did not contain 6 individuals, as had been reported for decades. It contained at least 12, and the 2 bodies positioned at the very center of the arrangement. The individuals long assumed to be the male ruler and a secondary male companion were, according to the new skeletal analysis, a man and a woman. That single correction unravels a great deal that had been built on top of the original interpretation. If the central figure of Cahokia's most significant known burial was not a solitary male ruler, but a paired man and woman, the entire warrior chief framework used to explain Mississippian political structure for half a century needs to be reconsidered. Emerson and his colleagues proposed an alternative reading, suggesting the burial may reflect themes connected to fertility, world creation, and dual cosmological principles, ideas found more broadly in Mississippian iconography, rather than a straightforward display of individual male military or political dominance. It is worth being precise about what this reversal does and does not prove. It does not mean Cahokia was a matriarchy, or that gender relations in this society mirror any particular modern framework. What it does mean is that the confident, decades-old story about a lone male ruler commanding absolute authority was built on an incomplete reading of the evidence, one that reflected, at least in part, the assumptions researchers brought to the material in the 1960s, more than what the bones themselves actually showed once examined more carefully. Researchers now argue for a more complex picture of paired or dual leadership, while remaining cautious about pushing that interpretation further than the physical evidence can currently support. New radiocarbon dating, conducted alongside the reanalysis, placed the core burial episode at Mound 72 between approximately 991 and 1023 AD, earlier than some previous estimates had suggested, and notably close to the period when the nearby Woodhenge timber circle was already in active use. That timing is not incidental. Archaeologists have long noted that the earliest burial features at Mound 72 were constructed directly over the location of dismantled Woodhenge posts, meaning this burial ground occupies land that had already carried ceremonial and astronomical significance before it became a place for the dead. The mound was not built on empty, meaningless ground. It was built deliberately on top of a site already invested with meaning. The grave goods surrounding the central pair reinforced the sense of extraordinary status, whatever the exact nature of their authority. Alongside the beaded falcon platform, excavators recovered caches of unused arrowheads, hundreds of finely made points that showed no signs of ever having been fired or used, suggesting they were crafted specifically as offerings rather than as functional weapons. Sheets and ornaments of worked copper, sourced, as the previous chapter traced, from deposits hundreds of miles to the north, were placed among the burial goods as well. Additional burials clustered near the central platform included other male-female pairs, some fully articulated and clearly buried intact. Others disarticulated, their bones gathered, bundled, and interred separately, suggesting a more complex, possibly staged mortuary process, rather than a single simultaneous burial event. None of this activity suggests violence directed at the central pair themselves. The man and woman at the heart of the beaded burial show no evidence of having been sacrificed. They appear to have died by unknown, likely natural causes, and were then honored with a scale of ceremony matched by almost nothing else excavated from this period in North America. That distinction matters, because it draws a sharp line between the reverence shown to this couple and what surrounds them in the wider mound, a line the next stage of the investigation crosses directly. Moving from the platform of shell and honored bone into pits that tell a far darker story about what this same society was willing to do to the living. Picture the moment the 1967 excavation team first uncovered the beaded platform, brushing back soil that had held this arrangement undisturbed for nearly 1,000 years. Shell does not decay the way bone or wood does over that span of time, so the beads would have emerged from the ground largely intact, thousands of small white discs still tracing the outline of a bird's wings and tail exactly as they had been placed. It is the kind of find that immediately signals importance, even before a single skeleton is fully exposed. A scale of deliberate artistic arrangement that could only belong to someone or something considered extraordinarily significant. Fowler's team recognized that significance immediately. What they could not fully recognize, working with the analytical tools available in the 1960s, was the more complicated story the skeletons themselves were quietly holding. It is worth understanding why the original identification of the central pair as two males held up for as long as it did. Sexing a skeleton from skeletal remains alone, particularly remains that have been in the ground for centuries and may be incomplete or damaged, is not always straightforward, and the methods used in the 1960s relied heavily on techniques and comparative standards that have since been substantially refined. Later analysis, applying updated methods for assessing skeletal indicators of sex. Along with a more careful re-examination of the original field notes and photographs Fowler's team had produced at the time, revealed that some individuals had likely been misidentified from the outset, not through carelessness, but through the limitations of the science available at the time. That kind of correction is not a small technical footnote. It illustrates something important about how archaeological knowledge actually accumulates. The 1960s excavation was not wrong to recognize Mound 72 as extraordinarily significant. It was wrong, in certain specific and correctable ways, about who exactly was being honored there and what that honor implied about the structure of Cahokian society. Reopening old field records and re-examining preserved skeletal material rather than treating the original 1960s report as a permanently settled conclusion is precisely what allowed the 2016 reanalysis to happen at all. A reminder that even a well-excavated, carefully documented site can still be holding information that later science is better equipped to extract. The revised timeline adds another layer worth sitting with. Placing the core burial episode between roughly 991 and 1023 AD means this extraordinary act of ceremony and construction occurred near the very beginning of Cahokia's rapid population growth described earlier in this investigation, not after the city had already reached its full scale, but close to the moment the Big Bang expansion was getting underway. That timing suggests the elaborate burial ritual at Mound 72 was not simply a later expression of wealth accumulated by an already established elite. It may have been part of the very process that established that elite's authority in the first place, a foundational act of ceremony helping to consolidate the social order taking shape as the population converged on the site. It helps to look more closely at what the original 1960s interpretation actually rested on, because it was never built purely from the skeletons themselves. Fowler's team was also working within a broader academic climate that expected to find male-dominated hierarchies at the top of complex ancient societies, largely because that pattern had been documented or assumed at other well-known archaeological sites elsewhere in the world. When ambiguous skeletal evidence met a strong prior expectation, the interpretation tended to resolve in the direction the expectation predicted. This is not a unique failing of Cahokia research specifically. It is a pattern archaeologists across many regions have had to reckon with as analytical methods improved, and as the field became more conscious of how assumptions can quietly shape the reading of ambiguous evidence. The unused arrowheads deserve a closer look as well, because they carry meaning beyond simple wealth display. Hundreds of finely worked points, uniform in style, showing nowhere consistent with having ever been shot from a bow, suggest they were manufactured specifically as funerary offerings, an investment of skilled labor with no practical use beyond the ceremony itself. Producing that many points to this level of craftsmanship, purely for burial, implies both a workforce of skilled toolmakers and a social system capable of directing a portion of that skilled labor towards ceremony rather than immediate practical need. That detail, small as it seems next to the dramatic bead platform, quietly reinforces the same picture built across earlier chapters: a society with enough surplus, specialization, an organizational capacity to dedicate significant resources to something other than survival. The couple at the center was not sacrificed, but almost everyone buried around them, in the layers and pits surrounding the beaded platform, was moved outward from the beaded platform into the surrounding pits of Mound 72, and the tone of the excavation changes completely, the careful ceremony of the central burial giving way to something colder and harder to reconcile with what came before it. In one large pit, archaeologists uncovered the remains of roughly 250 to nearly 280 individuals, the overwhelming majority young women between the ages of 18 and 23. They were arranged in neat, deliberate rows, laid out with apparent care rather than dumped or discarded. Their skeletons showed little to no evidence of physical trauma, no cut marks, no broken bones consistent with violence, no arrow points lodged among the remains. The most likely means of death, based on the lack of trauma combined with the deliberate arrangement, is strangulation or controlled bloodletting, methods that could end a life without leaving the kind of skeletal damage a blunt force killing or an execution by weapon would produce, before this evidence was fully analyzed. The initial interpretation offered by Fowler's excavation team in the 1960s treated these women as likely outsiders, tribute, in effect, brought in from surrounding communities to be sacrificed in honor of the elite burial at the center of the mound. This fit a familiar anthropological framework, powerful centers extracting sacrificial victims from subordinate or tributary populations, a pattern documented in a number of complex societies elsewhere in the world. It offered a relatively contained explanation. Cahokia's own people were not necessarily the victims. The violence, disturbing as it was, could be understood as directed outward, at captured or tribute-bound outsiders, rather than at the city's own residents. That explanation held for decades, until researchers applied a method capable of testing it directly. Strontium isotope analysis works by examining trace chemical signatures absorbed into human teeth during childhood, signatures that vary based on the local geology and water sources where a person grew up. Because tooth enamel forms early in life and does not change afterward, it effectively locks in a chemical record of where someone spent their childhood, regardless of where they later lived or died. Researchers Philip Slater, Kristen Hedman, and Andrew Thompson, working with the Illinois State Archaeological Survey and West Virginia School of Osteopathic Medicine, applied this method to teeth recovered from more than 100 individuals in Mound 72's mass burials. The results overturned the outsider tribute theory directly. The majority of the individuals tested, including most of the young women in the large row burial pit, showed strontium signatures consistent with growing up locally in the Cahokia region itself, not signatures matching distant communities the tribute theory would have predicted. This is where the story changes in a way that is genuinely difficult to sit with. If these were not captured outsiders brought in as tribute, but young women who had grown up within Cahokia's own sphere, possibly within the city itself, then the sacrifice at the heart of this burial complex was directed inward, at the society's own people, not outward at a subjugated other. That reversal reframes what kind of society is being described here. A society capable of sacrificing outsiders can still be understood uncomfortably within a framework of conquest, tribute, and external power projection, disturbing, but explicable through categories familiar from other historical contexts. A society capable of directing that same violence at its own population points towards something else, an internal hierarchy powerful enough and a belief system compelling enough to demand the deaths of its own young women, seemingly on a recurring basis rather than as a single unrepeated event. That recurrence is suggested by the physical arrangement of the burials themselves. Archaeologist Timothy Pocketot has argued, based on how the women were layered and grouped within the pit, that they were not all buried simultaneously in a single event, but rather in stages, consistent with the idea that a group of young women was sacrificed roughly once per generation, repeated across a span of years, as part of an ongoing ritual cycle tied to the site rather than a one-time act connected to a single individual's death. If that interpretation holds, Mound 72 was not the site of one dramatic sacrifice, but the site of a sustained, institutionalized practice carried out over years or decades as an accepted feature of Cahokian religious and political life. A practice repeated often enough that the community organizing it would have needed a stable, ongoing structure of belief and authority to sustain it across changing generations of leadership. A separate deposit within the same mound complex tells yet another version of this violence. In this pit, excavators found the remains of approximately 39 men and women, and the condition of their bodies could not be more different from the neatly arranged women nearby. These individuals showed clear evidence of violent trauma, decapitation, wounds consistent with arrow points, and severe fractures. Some remains showed evidence suggesting the individuals may have still been alive when placed into the pit. Based on the position of fingers found dug into the surrounding soil, a detail that researchers interpret cautiously but that points toward death, occurring during or immediately after burial rather than before it. Who these 39 individuals were and why their treatment differs so sharply from the women buried nearby remains one of the more genuinely open questions in the site's research. Some researchers have speculated they may represent captured enemies, political rivals, or individuals who resisted or objected to the practices being carried out, a theory that would explain both the violence of their deaths and the difference in treatment compared to the more ritualized, non-violent deaths of the women in the adjacent pit. Others caution that this remains interpretation, not established fact, and that the specific social category these individuals occupied in life may never be fully recoverable from skeletal evidence alone. The physical contrast between the two pits is not in dispute. One shows careful arrangement and an absence of trauma. The other shows violence and disorder. what that contrast meant to the people who created it is, and may remain, a genuine unknown. It is worth pausing on how uncomfortable this evidence has proven for popular retellings of Cahokia's story, precisely because it resists the two easiest narratives available. It does not support a romanticized picture of a purely peaceful, harmonious pre-Columbian society, free of the violence and hierarchy sometimes projected onto other ancient civilizations. Nor does it support an older, dismissive framing that treated native societies as incapable of complex political or religious organization. What the evidence actually supports is more difficult to sit with than either simplified version, a sophisticated, organized society capable of astronomical observation, continental trade, and large-scale construction that also organized recurring, institutionalized violence against members of its own community as part of its religious and political life. Holding both of those realities together without flattening one to make the other easier to accept is exactly what the physical record demands. What can be said with confidence, without overreaching into unprovable territory, is this: Mound 72 documents at least two distinct patterns of violent death, applied to different groups of people, integrated into the same ceremonial complex that also housed one of the most honored burials found anywhere in Mississippian archaeology. The physical record shows deliberate arrangement, repeated practice, and a clear social hierarchy capable of directing life or death decisions over its own population. What the physical record cannot show, and what the debate among researchers has not resolved, is the full belief system that made this violence meaningful to the people who carried it out. Whether as religious devotion freely accepted, as coerced political control, or as some combination the surviving evidence cannot fully separate. Stand at the edge of that excavated pit today, or look at the archival photographs taken as it was uncovered, and the neatness is what unsettles most. This was not a chaotic pile of bodies thrown together in haste. Each individual was positioned deliberately, aligned with the others, laid out in careful sequence, the kind of arrangement that requires time, coordination, and a group of people willing to perform the act of placement with something resembling ceremony rather than urgency. That care is in its own way more disturbing than a scene of obvious chaos would be. It suggests the people conducting this were not disposing of bodies in panic or in the aftermath of conflict. They were following a procedure, one practiced enough to be carried out with precision. Understanding how strontium isotope analysis actually works helps explain why this method could overturn a decades-old interpretation with this much confidence. As a child's teeth form, the enamel absorbs trace amounts of strontium from local food and water, and the specific ratio of strontium isotopes present varies depending on the underlying bedrock geology of the region where that food and water originated. Because different regions carry measurably different isotope ratios, and because tooth enamel does not change once it is formed. A person's teeth effectively carry a permanent chemical record of where they spent their early childhood, a record that survives even after death, embedded in mineral structure rather than soft tissue. By comparing the isotope signatures from the Mound 72 individuals against known baseline values for the Cahokia region and for more distant areas, researchers could test the outsider tribute theory directly rather than relying on inference from burial context alone. The result did not simply fail to confirm the outsider theory, it actively contradicted it. Most of the individuals tested carried strontium signatures consistent with a childhood spent locally within the broader Cahokia region. The opposite of what the original tribute-based interpretation predicted. That is the kind of reversal that forces a genuine reconsideration, not a minor adjustment. A theory that had stood as the standard explanation for one of the most significant mass burials in North American archaeology turned out to be built on an assumption the physical chemistry of the victim's own teeth did not support. A society willing to do this to its own people was not simply prosperous. It was operating under some form of internal pressure, whether religious, political, or both. And within a few generations of these burials, that pressure became visible in a very different kind of construction, not underground in a burial pit, but rising directly around the ceremonial heart of the city itself. Trace a line of dark, evenly spaced soil stains across an excavation grid near the base of Monk's Mound, and you are looking at the remnants of something the city's earliest builders did not include in their original plan: a wall. Not a ceremonial boundary or a symbolic marker, but a substantial defensive palisade built from thousands of upright wooden posts set closely together. Stretching roughly 2 to 3 kilometers around the central precinct containing Monk's Mound and the Grand Plaza. Archaeologists date its initial construction to sometime around 1150 to 1175 AD. Later rebuilt at least once, based on multiple overlapping lines of postholes found during excavation, suggesting the wall was maintained and reconstructed over a span of years, rather than built once and abandoned. Before this feature was fully understood, the assumption carried by earlier interpretations of Cahokia was that a city this prosperous, this centrally organized, and this connected to distant trade networks would have had little reason to fortify its own ceremonial heart. Wealth and religious prestige in this framework were more often associated with confidence and openness than with defensive anxiety. A civic center drawing pilgrims, traders, and migrants from across a continental network, as earlier chapters have described, does not obviously fit the profile of a place that needs walling in. The palisade complicates that picture directly. Building a wall of this scale is not a minor undertaking. It required felling and transporting thousands of substantial timbers, digging a continuous trench for the posts, and maintaining the structure over time as wood inevitably rotted and required replacement. That is an enormous diversion of labor and resources in a society that had already committed massive amounts of both to mound construction, craft production, and long-distance trade. A society does not spend that kind of effort on defense without a reason serious enough to justify the cost. What that reason actually was remains genuinely debated among researchers, and the debate itself is instructive because it resists a single tidy answer. One line of interpretation points outward, growing external tension. Whether from rival Mississippian centers competing for regional influence, from communities resisting incorporation into Cahokia's expanding sphere of trade and religious authority, or from more generalized instability as population pressure increased across the wider region during this period. Under this reading, the palisade reflects a city increasingly aware of threats beyond its own borders. Built as the city's growing prominence also made it a more visible target. A second line of interpretation points inward, toward internal social strain rather than external conflict. This period, roughly contemporary with the palisade's construction, also corresponds with the era when the mass sacrifices documented in Mound 72 were most active. According to some of the dating evidence discussed earlier, a society organizing recurring, institutionalized violence against its own population, on the scale suggested by the burial evidence, may also have needed to secure its ceremonial core against internal dissent, factional rivalry among competing elite lineages, or resistance from within its own community to the demands being placed upon it. Under this reading, the wall is less a shield against outside enemies and more a boundary asserting control over who could access the city's most sacred and politically significant spaces, separating an inner circle of authority from a broader population whose full cooperation could no longer simply be assumed. Weighing these two explanations against each other is less a matter of choosing a winner than of holding both possibilities honestly. External pressure and internal strain are not mutually exclusive, and a city under stress from one direction often experiences stress from the other simultaneously, each reinforcing the conditions that make the other more likely. A community facing outside competition for resources or prestige may also experience sharper internal divisions over how to respond, just as a community already fractured internally may become more vulnerable to outside pressure. The palisade may represent a physical response to exactly that kind of compounding stress, without the archaeological record being able to specify which pressure came first or weighed more heavily in the decision to build. Neither interpretation currently has decisive physical evidence tipping the balance fully in its favor. What the excavated postholes can prove is the wall's existence, its approximate dimensions, its construction date, and evidence that it was rebuilt more than once. What they cannot prove, on their own, is the specific motivation behind the decision to build it, a limitation researchers are careful to acknowledge rather than paper over with a more satisfying but less supportable narrative. There is a version of this evidence that risks becoming misleading if handled carelessly. The temptation to frame the palisade as proof of some dramatic, singular catastrophe, an invasion, a war, a violent uprising that nearly toppled the city. The physical evidence does not support that dramatic a reading. There is no layer of destruction debris, no mass grave connected specifically to a battle event, no burned structures dated precisely to the palisade's construction that would indicate the wall was a desperate emergency response to an ongoing attack. What the evidence supports is more measured, and in some ways more unsettling precisely because it is less dramatic, a sustained, planned defensive structure, built and rebuilt over years, suggesting an ongoing condition of concern rather than a single crisis. It is worth comparing this evidence against what a genuine conflict event typically leaves behind in the archaeological record elsewhere, to understand why researchers are careful not to overstate what the palisade alone can prove. Sites associated with documented warfare in other regions and periods frequently show burned structures dated to a narrow, shared window, skeletal remains bearing weapon trauma clustered around the same event, and material culture abruptly interrupted or abandoned mid-use. Cahokia's central precinct, during the period of the palisade's construction and rebuilding, shows none of those specific signatures. The absence of that evidence does not prove peace. It simply means the wall, on its own, cannot be read as proof of active war, however tempting that dramatic interpretation might be for a documentary framing eager for a clear villain or a decisive battle. That ongoing condition, whatever its precise source, arrives at a specific moment in the city's broader timeline worth holding in mind. The palisade's construction, beginning around 1150 to 1175 AD, falls roughly a generation or two after Cahokia's population had reached its peak, and roughly a generation or two before the climatic and agricultural pressures discussed in the coming chapter began to intensify. Positioned between the city's high point and its eventual decline, the wall reads less like a symbol of confident strength and more like an early physical symptom of stress beginning to accumulate beneath the surface of a still functioning, still populous city. Stand where the palisade line would have run today, and there is nothing to see. Open grass. The same quiet park atmosphere found across most of the site, joggers and picnickers moving unknowingly across a boundary that once separated the sacred center of a continent spanning city from everything outside it. But picture that same ground 1,000 years ago, a continuous wooden barrier tall enough to obscure sightlines into the plaza and mound complex beyond it, cutting the ceremonial heart of the city off from the residential neighborhoods surrounding it. Whatever the wall was meant to keep out or keep contained, it marks the moment archaeological evidence first shows this city treating its own center as something that needed protecting. Understanding what archaeologists actually found in the ground helps clarify why they are confident calling this a defensive structure rather than a ceremonial boundary or a simple property marker. The posts were set close together, deep enough to support significant height, and arranged in a continuous line rather than the scattered or discontinuous pattern typical of ordinary fence lines or ritual enclosures found elsewhere at the site. Excavators also identified what appear to be bastions, projecting sections built at intervals along the wall's length, positioned in a way that would have allowed defenders standing at those points to see and potentially defend the wall's flanks, a design feature associated specifically with defensive fortification rather than symbolic enclosure. That detail matters, because a purely ceremonial boundary has no functional need for flanking bastions. Their presence argues strongly that whoever built this wall was thinking specifically about the practical mechanics of defense, not simply marking a sacred perimeter. The scale of labor required for this project is also worth measuring against everything the city was already doing at the same time. Felling and transporting the number of large timbers needed for a wall spanning multiple kilometers would have required organized woodcutting expeditions, likely drawing on forested areas at some distance from the immediate floodplain. Since sustained mound construction and residential building had already placed heavy demand on nearby timber resources for generations. Combine that demand with the ongoing labor still required for the mound complex, for craft production feeding the long-distance trade network, and for the agricultural system supporting a population in the tens of thousands. And the palisade represents a significant additional strain on a labor pool that was already fully committed to other large-scale projects. That additional strain is itself a kind of evidence. A society does not divert labor at this scale from other essential projects unless the perceived need for defense outweighed the cost of delaying or reducing other work. Whatever was driving the decision to build this wall, it was serious enough to compete successfully against the ongoing demands of mound construction, trade, and agriculture for a share of the city's finite labor supply, a strong indication that concern, whether about external threat or internal control, had become a genuine priority for the city's leadership during this period. A city walling itself in is a city that senses something is wrong, even if the exact nature of that wrongness resists a single, confident explanation. And not long after the palisade's final rebuilding phase, a different kind of evidence entirely, carried not in postholes but in the mud at the bottom of a nearby lake, began to show that the climate itself, the very force that had helped build this city in the first place, was beginning to turn against it. Pull a sediment core from the bottom of Horseshoe Lake, the shallow body of water that once served as Cahokia's primary catchment basin, and you are pulling up a layered record of centuries, compressed into a cylinder of mud no wider than a human arm. Dense with information no human witness left behind in any other form. Each thin band within that core represents a slice of time, pollen grains revealing what plants grew nearby, charcoal flecks marking burning events, chemical traces shifting with changes in land use along the shoreline above. Read carefully, cross-referenced against tree ring records from the surrounding region. This mud tells the story of what happened to Cahokia's climate after its population reached its peak, and the story it tells is not a gentle one. Earlier chapters described how a warm, wet climatic window around 1050 to 1100 AD likely helped fuel the agricultural surplus behind Cahokia's rapid population growth. That same body of research, drawing on the work of Larry Benson, Timothy Pocketot, and Edward Cook, published in American Antiquity, shows that the climate did not stay favorable. Beginning sometime in the early 12th century and intensifying through the following century, the region experienced a shift toward persistent drought, with tree ring records indicating unusually dry conditions extending across much of the period between roughly 1100 and 1245 AD. Layered on top of that drought pattern, the same period also saw major flooding events disrupting the floodplain agriculture the city depended on. A punishing combination in which dry years starved crops of water, while intervening flood years drowned fields or buried them under silt, leaving farmers with narrow, unpredictable windows in which conditions actually supported a good harvest. Before this data was fully assembled, the operating assumption in earlier discussions of Cahokia's decline tended to treat the city's size and organizational sophistication as a form of resilience in itself. A large, well-organized, agriculturally productive civilization, the reasoning went, should have had the capacity to weather ordinary environmental fluctuation better than smaller, less centralized communities nearby. Scale and complexity were assumed to buy a measure of protection against the kind of climate stress that might devastate a more marginal settlement. The evidence complicates that assumption directly. Cahokia's very success may have made it more vulnerable to exactly this kind of environmental shock, not less. A population in the tens of thousands, concentrated densely within a relatively small urban core, depended almost entirely on a single staple crop grown on floodplain soils directly exposed to both drought and flood risk. That concentration, which had made Cahokia's rapid rise possible in the first place, also meant the city had comparatively little buffer once the climate turned against it. A smaller, more dispersed population, spread across a wider area with more varied local conditions and food sources, might have had more flexibility to adapt as growing conditions shifted. Cahokia's scale, in other words, cut in both directions, an engine for extraordinary growth during the favorable window, and a liability once that window closed. The physical evidence of agricultural stress extends beyond the climate record itself into the archaeological record of what people were actually eating. Analysis of fish remains recovered from occupation layers dated to the drought period shows a measurable decline compared to earlier periods, consistent with reduced water levels in the rivers, sloughs, and backwater lakes that had previously supported a reliable fishing economy, supplementing the city's maize-dependent diet. That decline matters because it shows the environmental stress was not confined to a single crop or a single resource. Drought conditions severe enough to reduce fish populations in the surrounding waterways would have simultaneously strained agricultural yields on the floodplain, compounding food insecurity across multiple sources at once, rather than leaving one reliable fallback available while another failed. Geochemical analysis of sediment cores recovered from lakes near the site adds another layer to this picture, one connected less to climate directly and more to the consequences of the city's own construction activity over the preceding centuries. Evidence from these cores indicates measurable soil erosion and land disturbance consistent with large-scale deforestation, likely tied to the enormous demand for timber used in mound construction, residential building, and, as the previous chapter described, the palisade wall itself. A landscape stripped of tree cover to support centuries of construction would have been considerably more vulnerable to the erosion and runoff problems that intensify during both drought and flood conditions, meaning the environmental stress Cahokia faced in this period was not purely an external climatic imposition. It was, in part, environmental degradation. The city's own success had helped set in motion a pattern that shows up in similar form at other pre-industrial urban centers around the world that outgrew the immediate carrying capacity of their surrounding landscape. This is where the story resists the easy shorthand sometimes used to describe collapse narratives, the idea of a single, dramatic tipping point, a last bad harvest, a final flood that ended everything at once. What the layered evidence actually shows is closer to a slow erosion of margin for error. A city operating at the edge of what its environment could reliably support during good years has little buffer left once conditions turn unfavorable for a sustained stretch. Cahokia's population had grown to match the extraordinary agricultural output of a uniquely favorable climatic window. When that window closed, the population the city had to feed did not shrink as quickly as the land's capacity to feed it did, creating exactly the kind of gap that tends to produce gradual contraction rather than sudden collapse. What can be said with confidence, without collapsing this into a single tidy cause, is that Cahokia's decline in this period reflects the interaction of several compounding pressures rather than one clean explanation. Persistent drought reduced agricultural reliability. Flooding disrupted farming, and the year's drought did not. Deforestation tied to generations of construction likely worsened the land's capacity to absorb these environmental shocks. And the social strain suggested by the palisade wall and the pattern of institutionalized sacrifice documented earlier may have made the city less resilient to crisis precisely when resilience mattered most. If internal cohesion was already under some measure of strain before the climate turned. Most researchers agree these factors combined rather than acted alone, though the relative weight each one carried in the city's eventual decline remains a genuinely open question. The consequence of these compounding pressures shows up clearly in the archaeological record of the city's population over the following generations. Excavated occupation layers, dated to the period after roughly 1200 AD, show a steady contraction, fewer new residential structures, reduced evidence of the specialized craft production that had characterized the city's peak, and a gradual thinning of the dense population that had once filled the floodplain. By approximately 1350 to 1400 AD, the archaeological evidence indicates the city's core had been largely abandoned. The mounds remained standing, but the residential neighborhoods, the workshops, the crowded plaza that had once rivaled a European capital in population had emptied. It helps to understand precisely how a core of lake mud becomes a climate record at all, since the leap from sediment to drought history is not obvious on its own. As sediment settles year after year on a lake bottom, it forms a continuous, largely undisturbed sequence of thin layers, each one reflecting conditions at the time it was deposited. Researchers extract a long cylindrical core straight down through these layers, then analyze it section by section, moving backward through time as they move deeper into the tube. Oxygen isotope ratios preserved in certain minerals within the sediment shift measurably with changes in regional rainfall and temperature, giving researchers a chemical proxy for climate conditions even in the absence of any written record. Cross-referencing that proxy against independently dated tree ring sequences from the same region allows scientists to build a climate timeline with enough precision to align, almost year for year, against the archaeological chronology of the city itself. That precision is what makes the overlap between climate and decline so difficult to dismiss as coincidence. The drought period identified in the tree ring and sediment record does not merely fall somewhere in the general vicinity of Cahokia's decline. It aligns closely with the specific window during which archaeological evidence shows population contraction accelerating, agricultural indicators weakening, and residential density thinning across the excavated core. When multiple independent lines of evidence, tree rings, lake sediment, excavated fish remains, and settlement pattern data all point toward the same narrow window of environmental stress, the case for a genuine causal relationship, rather than a loose correlation, becomes considerably stronger. It is worth pausing to imagine what this slow decline would have actually looked like on the ground, without overstating what the evidence can specifically confirm. Fields that had reliably produced surplus maize for generations beginning to fail more often than they succeeded. Fishing expeditions returning with smaller catches as water levels in the surrounding sloughs dropped. Storage systems designed to carry the population through ordinary lean years increasingly strained by conditions that were no longer ordinary. None of that is documented in any single artifact. It is the plausible, evidence-grounded texture behind numbers that otherwise remain abstract, a population contracting, a landscape drying. A city built for abundance, slowly confronting scarcity it had not been designed to withstand. By 1400, Cahokia stood empty. For centuries, that emptiness was treated as an ending, the final chapter in the story of a remarkable but doomed civilization. A lesson in the fragility of even the most impressive human achievement when climate and environment turn against it. But a new kind of evidence, found not carved into stone or shaped from copper, but preserved in the most unglamorous material imaginable, ancient human waste, settled into the mud at the bottom of a nearby lake, would eventually prove that assumption incomplete in a way few researchers had anticipated. Return, one last time, to the top of Monk's Mound at dawn. The mist still settles low over the floodplain the way it did in the opening moments of this investigation. The grass is the same grass. The modern skyline of St. Louis still catches the first light in the distance, glass and steel a few miles from a hill of hand-carried earth. Nothing about the physical scene has changed since the first image of this story. What has changed is everything you now know about what that scene actually contains. Before this investigation began, a visitor standing here saw a large, unusually symmetrical hill, and perhaps a vague awareness that Native Americans had built it at some point in the past. Now, standing in the same spot, that hill carries the weight of a population that once matched a medieval European capital. It carries a solar calendar precise enough to align an entire city's layout with the movement of the sun. It carries copper from the Great Lakes and shell from the Gulf of Mexico, moved here across a trade network spanning much of a continent. It carries a burial complex where a man and a woman were honored with a bed of 10,000 shell beads shaped like a falcon, while, in the pits surrounding them, hundreds of the city's own young women were sacrificed, seemingly on a recurring cycle, for reasons the physical evidence can document but not fully explain. It carries a defensive wall built around its ceremonial heart during a period of unresolved internal or external tension. And it carries the layered record of a climate that first made the city's extraordinary growth possible, then turned against it with a persistence the city's own success may have made harder to survive. For most of the 20th century, the story ended there, with abandonment, sometime around 1350 to 1400 AD, treated as a final chapter rather than a transition. That framing fit comfortably into a larger, older narrative, sometimes called the myth of the vanishing Indian. The assumption that Native American presence in a given region simply ended once a particular archaeological culture declined, clearing the way, in the popular imagination, for an empty landscape awaiting European arrival centuries later. Cahokia's dramatic rise and fall made it an especially convenient anchor for that narrative, a spectacular civilization that supposedly rose, peaked, and then disappeared, leaving behind only earthworks and unanswered questions. In 2020, a study published in American Antiquity, led by A.J. White, then a doctoral student at the University of California, Berkeley, working alongside researchers from California State University Long Beach, the University of Wisconsin-Madison, and Northeastern University, directly challenged that ending. The evidence they used to do it came from an unlikely source: fecal stanals, chemical compounds produced by digestion and preserved for centuries in lake sediment, that allow researchers to estimate relative human population levels in a watershed over time, even in the absence of any standing settlement or excavated structure. Because these compounds accumulate in the mud, regardless of whether anyone is actively building monuments or leaving behind pottery, they can detect a human presence that traditional archaeological survey, focused on visible structures and artifacts, might otherwise miss entirely. The fecal stanal record from Horseshoe Lake, the same lake whose sediment had earlier revealed Cahokia's climate history, showed something the visible archaeological record alone had not made clear. Population levels in the region did not simply flatline into emptiness after Cahokia's decline. Instead, the evidence indicates a new wave of Native American population re-established itself in the area beginning around the 1500s, sustaining a continuous presence through the 1600s and into the 1700s, a presence that persisted for roughly 2 centuries before European colonization, warfare, disease, and forced displacement finally disrupted it in the centuries that followed. That finding requires a careful redrawing of the old picture, not a wholesale rejection of everything previously understood about the city's decline. The Mississippian culture that built Monk's Mound, organized the sacrifices at Mound 72, and constructed the Palisade Wall did decline as a distinct cultural and political entity, for the combination of climatic and social reasons traced across earlier chapters. But the disappearance of that specific culture from the archaeological record was not the same thing as the disappearance of Native American people from the region. New communities, whose specific origins and identities the current evidence cannot always resolve with precision, moved into the area, adapted to its resources, and maintained a presence there for generations, a presence invisible to survey methods that only look for structures and artifacts, but clearly detectable in the chemistry preserved at the bottom of a lake. One would think the Cahokia region was a ghost town at the time of European contact. Based on the archaeological record, White noted when the findings were published, describing the assumption the fecal stanal data directly overturned. The corrected picture is more complicated, and in some ways more difficult to summarize neatly than the older narrative of rise, peak, and vanishing. It is also, in an important sense, a more honest reflection of what continuity and resilience actually look like on the ground, not an unbroken, unchanging presence, but a series of migrations, adaptations, and renewals playing out across centuries, largely hidden from view until the right scientific method was applied to the right material. This reframing connects directly to the deeper mystery running beneath every chapter of this investigation, the absence of the builder's own voice. Cahokia's name for itself did not survive. The specific beliefs behind the solar alignment of Woodhenge did not survive in full. The exact reasoning behind the sacrifices in Mound 72, and the precise nature of the threat or tension that led to the Palisades' construction, did not survive either. What survived instead is physical evidence, patiently reassembled by generations of researchers willing to keep questioning their own previous conclusions, willing to re-examine 50-year-old skeletons, reread old field notes, and test old assumptions against new chemical methods that did not exist when the first excavations took place. That willingness to keep questioning is, in its own way, the closest thing this story has to a moral. The 19th century got Cahokia badly wrong, inventing a fictional lost race rather than crediting the ancestors of the people who lived on this land. The 20th century corrected that error, but still carried forward smaller, more subtle assumptions about gender, about hierarchy, about who counted as an outsider worth sacrificing and who counted as a member of the community, about whether decline meant disappearance. Each of those assumptions has since been tested against new evidence, and each has had to be, at least partly, redrawn. There is no reason to assume the current understanding of Cahokia represents a final, settled account. It is simply the most current chapter in a story that keeps revising itself as new methods reach further into what the ground has kept quiet. The sun is fully up now over the mound. A jogger passes along the path, circling its base, headphones in, unaware or only vaguely aware of what lies beneath the packed earth underfoot. Somewhere in a museum drawer a few miles away, a shell bead sits behind glass, cut and polished by hands that moved with purpose 1,000 years ago. For reasons that can be partly reconstructed and partly only guessed at, the mound itself has not changed shape in centuries. What has changed, slowly, patiently, one excavation and one reanalysis at a time, is how much of its story we are finally able to read. The past did not disappear here. It simply waited, quietly, for someone to keep asking the right questions. And it is still not finished answering.